Welcome to this explainer. Today, we're diving into the fascinating mechanics of algebra to discover how math actually reflects logical and relational truth. We aren't just pushing numbers around a page here. We're looking at what happens when completely different paths cross. Finding that exact point of intersection, it's a real game changer for solving complex problems in both math and life. To set the stage, our source material anchors this whole idea with a quote from Ecclesiastes 4:9 through 10. Two are better than one, for if they fall, one will lift up the other. Just as people work best in unity, we're going to see today that mathematical lines, much like people, are absolutely most impactful where they connect. There's a profound shared strength in that intersection. So here's our roadmap for today. 1. The power of 2. 2. Why systems matter. 3. The 3 possible outcomes. 4. Seeing it in action. 5. Your turn to practice. And 6. Education, morality, and peace. Let's get right to it. Section 1. The power of 2. Okay, so a system of linear equations is simply two or more linear equations plotted on the exact same graph. Now, the big idea here, and this is absolutely crucial, is that the solution to this system is the exact point where those lines cross. That single coordinate point makes both equations perfectly true at the exact same time. It's like a mutual agreement between two completely different mathematical statements. Moving on to Section 2, Why Systems Matter. Now, you might be wondering, why do we even care? Well, whenever two conditions must be true at once, systems of equations are working behind the scenes. Whether you're balancing a business budget, diving into strategic planning, comparing subscription rates, or trying to predict future outcomes, you are using these systems. They give you the tangible, visual proof you need to make confident decisions when you're juggling multiple variables.
Which brings us to Section 3, the 3 possible outcomes.
When we put two lines on a graph, there are specific rules of engagement you'll want to memorize. First, if the lines intersect at one single point, boom, you have exactly one solution. Second, if the lines run parallel and never ever touch, well, there's no solution because they just never agree. And third, if the lines sit directly on top of each other like they are literally identical, you have infinitely many solutions because they agree absolutely everywhere. Section 4, Seeing it in action. Let's slow things down and look at the math. Let's look at our first example. We have the equations y equals x plus 2 and y equals negative x plus 4. Notice how these two equations have totally different slopes. Because one is pointing up and the other is pointing down, they will absolutely cross paths. And when graphed, they meet perfectly at the coordinates 1, 3. Boom, that is our one singular solution. For our second example, look really closely at the slope of both of these equations. We've got y equals 2x plus 1 and y equals 2x minus 3. Because they both rise by a factor of 2x, their angles are exactly the same. But since they start at different points on the y-axis, positive 1 and negative 3, they're parallel lines. They'll run alongside each other forever and yield zero solutions. No intersection, no solution. And this brilliantly illustrates our third scenario. Check this out. We start with y equals 3x plus 2, and 3x minus y equals negative 2. They look pretty different at first glance, right? But if you use your algebra skills to rearrange that second equation to solve for y, you're going to realize it's the exact same line. Since they are literally the same line, they intersect everywhere. That gives us infinite solutions. Section 5. Your turn to practice. Our source material actually encourages you to pause the explainer right here. Seriously, grab some graph paper and test your skills on question 1. For question 2, take a hard look at those slopes to deduce the answer. And for question 3, I want you to really think about what we discussed earlier regarding budgets and planning to articulate what that intersection actually means in the real world. The curriculum then adds 2 final questions to the list to really bring it home. Question 4 is going to test your graphing precision, and question 5 is specifically designed to solidify your ability to deduce the number of solutions just by manipulating the equation and analyzing those slopes and intercepts. And finally, Section 6, Education, Morality, and Peace. Let's tie this all together. According to the HeroesMart Academy Godly Learners series, the crucial point of this whole lesson is that learning math, science, and literature should always be paired with right living. Their core philosophy states that academic brilliance without a moral compass ultimately leads to pain. The idea is that education without morality will hurt, because having knowledge without the wisdom to use it often leads down destructive paths.
To back this up, the curriculum points to Romans chapter 8, verses 6 and 7, highlighting a promise of peace of mind to everyone who keeps their mind spiritual. The source argues that when students align their academic education with this foundational truth, the promised result isn't just being smart, it's absolute peace of mind.
The lesson leaves us with a really provocative thought to ponder today. What is the point of being smart and supposedly educated if we continue to make bad choices that hurt ourselves and those around us? The curriculum urges that as you master systems of linear equations, you should also strive to make sure your intelligence intersects perfectly with a strong moral foundation. Thanks for joining me on this explainer, and I'll catch you on the next one.